You know, when you think about 3D printing, your mind probably jumps to those little plastic doodads, right? But the technology is taking this massive leap forward, way beyond simple polymers. So, let's dive into the next frontier, 3D printing super strong ceramics. We're going to be exploring some amazing perspectives from a presentation by James Tsoi that really breaks it all down.
I mean, just think about that for a second. What if you could create objects with the raw strength of industrial-grade steel, but with the mind-bending complexity of a delicate sculpture? And you could do it all straight from a computer file. This isn't science fiction anymore. This is the real promise of printing with advanced ceramics.
And meet zirconia. This material is the star of our show today. It is incredibly tough stuff, and what you're looking at here is this unbelievably complex lattice structure that was printed with it. Now, this is not something you're going to make on your desktop printer at home. This is the result of some seriously cutting-edge science and engineering.
So, how in the world does this even work? Let's get into the basics of how you actually print with these incredible materials.
Okay, so at its heart, 3D printing is a pretty straightforward idea. You have a digital design on a computer, and a machine builds it one paper-thin layer at a time until a real physical object just appears. The magic, and of course the biggest challenge, comes down to the material you decide to build with.
And to really appreciate why this is such a game changer, you have to understand how totally different it is from the way we've been making things for centuries. On the left, that's the old way, subtractive manufacturing. You start with a big block of material, and you just carve, drill, and grind away everything you don't want. Think of a sculptor with a block of marble. But on the right, that's the new way, additive. You start with absolutely nothing, and you build the object up layer by layer, only using the exact material you need.
So the payoff for building things this way is huge. You can get from an idea to a physical part way, way faster. You can design these super complex shapes, even with intricate internal structures that would be totally impossible to carve. And because you're not wasting a mountain of material, you save a ton on cost and time. It's a win-win-win.
But this all leads to the big question, right? The central problem in this whole story. If this is so amazing, why isn't everything being printed with these super strong ceramics?
Well, as it turns out, working with ceramics is incredibly difficult. They are brittle, they react to things like heat and light in really tricky ways, and frankly, they don't always like to cooperate with the laws of physics.
I mean, researchers are up against a whole list of challenges. The light that's used to harden the material can kind of bleed out and mess up the fine details. The parts themselves can warp and shrink as they're being made. And, good old gravity is always there trying to make things sag, especially on parts that stick out without any support.
Now, this light scattering problem is really fascinating. Imagine each little pulse of light from the printer is like a single drop of ink on paper. By itself, it's just a dot. But when you put a bunch of dots close together, they start to bleed into each other, right? That's exactly what happens with the UV light used to cure the ceramic. It scatters and hardens areas it isn't supposed to, blurring all the sharp, precise lines of the design.
And then, of course, there's gravity. What you're seeing here is what happens to parts that hang over empty space. They're called cantilever beams. If there's no support structure underneath them, the wet, gooey material just droops and deforms while it's printing, and that completely ruins the part's final shape and accuracy.
So how do you fix these massive problems? Well, the researchers we're looking at found the answers by focusing on a really demanding, high-stakes application, creating a perfect dental crown.
To nail down that light scattering issue, they got super methodical. They printed tons of these tiny little holes with very specific digital measurements. Then they just measured the actual printed holes. The difference between the two told them exactly how much the light was bleeding, which let them build a mathematical model to perfectly counteract it. So clever.
And they did the same thing for the gravity problem. They just ran these methodical tests, printing these L-shaped beams at steeper and steeper angles. And if you look at that graph, you can see the exact moment where it all goes wrong. See that blue line? It just spikes right around the 65-degree mark. That's it. That's the tipping point, the critical angle where the structure just can't hold its own weight anymore.
And this just brilliantly shows you the real-world payoff. Now, the software can scan a complex shape, like a tooth, find every single surface that's steeper than that 65-degree limit, and then automatically build in the support structures it needs. The result? A perfectly accurate print every single time.
So they've solved for strength, they've solved for precision, But what about making things look good? What about aesthetics? Well, that's where the next incredible innovation comes into play.
Okay, this is where things get really, really clever. The researchers actually designed a custom printer nozzle. It takes in two different materials, in this case, one black zirconia and one white zirconia, and it feeds them into this special chamber called a static mixer. This little device perfectly blends the two materials together right before they come out of the nozzle.
And just look at these results. They're absolutely stunning. By precisely controlling the mix of black and white material going in, they could create this perfectly smooth, totally predictable color gradient. You're seeing the test blocks here going from 100% white all the way to 100% black with all those beautiful shades of gray in between.
And this is the grand finale. It's the culmination of all that work. It's a complex vase printed with a seamless color gradient, and it's not only beautiful, but also incredibly accurate. They've managed to combine the strength of ceramic, the precision of their corrected printing process, and now the aesthetics of multicolor design all in one piece.
Which brings us right back to where we started. If you can print strong, precise, multicolored ceramics like this, what's the limit? Seriously, imagine walking into a dentist's office and walking out just minutes later with a perfect custom-colored tooth that was printed right there, just for you. That future might be a whole lot closer than you think.